So, hello student. Today we will learn about NCRT maths from class 9. So, NCRT math class 9. So, this will help you in CBSE and ICSE both this lecture. So, today's first chapter is number system. First chapter, chapter 1. Number system. So in number system chapter, we will see what is number. So what is number? And we know numbers are this all 0, 1, 2, 3, 4 dot dot infinity, or it's plus minus all. And it includes fractions also, rational, irrational also. Now in number system, we have to know that how these numbers came. First of all, we will tell about natural numbers or counting numbers. Natural number and counting numbers. So whenever we are counting, we starting from 1, 2, 3, 4. This way we are continuing. Sometimes mathematicians are telling that these natural numbers is given by the God only. So this 1, 2, 3, 4 dot dot infinity, these all numbers are called natural numbers. Now one more type of number is required. Suppose we are going to solve x plus 1 equal to 1. So it implies x equal to 0. But our previous collection in natural numbers, we don't have 0. So we have made another collection, that is whole numbers. Whole numbers. So whole numbers including 0 and all the natural numbers. So from this we can ask a question that is all the whole natural number is whole number? Is all the natural number whole number? So the answer will be no. Answer will be no. Here 0 is not included. Is all the natural number whole numbers? No, answer will be yes here, because it's telling about all natural number, and whole number contain all the natural number also. So which is the smallest whole number? This one also can be a question. Which is the smallest whole number? Which is the smallest whole number? So the answer what will be the answer? Answer will be 0 is the smallest whole number. 0 is the smallest whole number. Zero is the smallest whole number. Now question number 3 is telling that which number is how many numbers is there in a whole number collection? How many numbers are there in whole number collection? Whole number collection. So the answer will be there are infinite number of whole numbers. There are infinite number of whole numbers. Now, how do you represent the whole numbers on the number line? Represent whole numbers on the number line. So we have to represent the whole numbers on the number line. To represent it, we will make the number line. Then we will take a point 0, and we know that the right side of the 0 is positive. So this is a line in equal length. We will take the numbers. These equal length points represent one numbers. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here, this is the representation of the whole number, and this arrow sign telling about the infinite length of the line. Here, the line which has infinite length, infinite length is telling about is telling about the infinite numbers of whole numbers, infinite numbers of whole number. Because, and these all are the positive whole numbers. Now we will see some properties of whole number with respect to addition, then subtraction, addition, subtraction, multiplication, and division. So see that with respect to whole numbers, so we will draw a line where this line telling about the type of numbers, and here we will take addition, then subtraction, multiplication, and division. So see, so here we writing addition, then subtraction, then multiplication and division. And here we are writing whole numbers. So if you add two whole numbers, it is again a whole number. So this satisfied. Okay, right here, commutative as closure property, and in this place, here we will write whole number. Whole numbers, and here we will write closure property, closure property. Then commutative, then it will be associative. So with respect to addition, this will be a commutative, it will hold commutative property or not. So how do you understand that thing? So for that, we have to check two integers, two whole number. If you take, their sum always will be whole number. So that means with respect to addition, it's always a closure property, it satisfies closure property. But with respect to subtraction, it will not satisfy the closure property, because suppose 2 minus 3, 2 and 3 both are whole number, and we have applied the which we have applied subtraction between 2 and 3. So these 2 and 3 applied, but 2 minus 3 we got minus sign. So, and we know that in whole number, no negative numbers are there. Multiplication of two whole numbers is always a whole number. So this one is also satisfying the closure property. Now division. division is satisfying or not. No, division is not satisfying the closure property. Similarly, commutative property, if you add, suppose two whole numbers 2 and 3, so 2 plus 3 and 3 plus 2 both gives the same value. So that's why with respect to addition, whole number is commutative. But the commutative will not be applicable for subtraction in case of whole number. But in case of multiplication, commutative will be whole. So this is yes, and for division, it will be no. So you can take two numbers, suppose 2 by 3. This is not a whole number, not a whole number. So that's why the division 2 by 3 or 3 by 2, both is not a whole number. If one counter example you got, you can write this. That division is not commutative. Now associative. So associative with respect to addition will be satisfied, but subtraction will not be. Multiplication will satisfy, again division will not. Now identity element. Identity element. What is the identity element? Zero with respect to addition. So in case of whole number, identity element is 0 with respect to addition. Since 0 plus a, 0 plus a or a plus 0, both gives the value a. Here 0 do not does not change the value of other numbers. So it keeps the identity. So 0 is the identity element. Now we will see identity element with respect to identity element is 1 with respect to multiplication. So with respect to multiplication, identity element is 1. So we can write, suppose 1 into 5 or 5 into 1, both will give you 5. Now additive inverse. So there have no additive inverse. There have no additive inverse. In whole number. Then there have no additive inverse because additive inverse of 5 is minus 5 in case of integers. But here we will not get any negative numbers, so we will not get any additive inverse also. There are no additive inverse in whole numbers. Now distributive property. So distributive property of whole numbers with respect to addition and multiplication. With respect to with respect to addition over multiplication. So we have to see and one example here. Suppose 2 into 3 plus 5. So here we see right respect to multiplication over addition. So here this will be 2 into 3 plus 2 into 5. So this gives us 6 plus 10, that is 16. So similarly, this will be possible to write 3 plus 5 into 2. Same thing it also. So this is telling about the distributive law. So here, if it is given like this, so we will do first the commutative law here. We will use commutative law. How will be that 2 into 3 plus 5? Then we will apply again distributive law. So today's class is up to this only. We learn about whole number. We learn about natural number and why this whole number is taken. We have seen that smallest whole number. Then why this small whole number collection is taken. Then which is the smallest whole number, how many numbers are there in whole number, that is infinite, how to represent the whole number on the number line, and the properties which we very familiar: closure property, commutative property, associativity, and we have seen identity element, and we have seen there is no inverse element, identity element with respect to addition, with respect to multiplication, then distributive property. This we have seen. So this much is for today. So thank you. Have a nice day.